So today what we're going to do is we're going to talk about angles of elevation and depression. So on your sheet you'll notice we have what are we doing today. So we'll have something that looks like this. Use the angles of elevation and depression to solve triangles. How do we know if we understand what's going on? Well, we'll basically draw a triangle for every situation or word problem that we're working on, and then we're going to use SOHCAHTOA to find an angle or a side. Now, you'll notice that we have this horizontal line here. Now, this horizontal line is just a pictorial example of what we're talking about today with angles of depression and elevation. So imagine that you're looking from a window or you're looking from the ground. Your eyes are at horizon level, so if you look directly out parallel to the ground, that's called a horizontal line. Now, this is what the angle of depression is, and this is what the angle of elevation is. And you'll see the angle of elevation is measured from the horizontal line, or the horizon, or your eye that is parallel to the horizontal line and measured up. Now this is what we mean by the angle of depression. The angle measured from the horizontal down. This is called the angle of depression. Now, for word problems, it says we have 3 steps that we have to answer for every word problem. We'll talk about it in a minute. But first, we'll do the problem. We'll do the first problem of the day, and then we'll go back to these steps. For our word problem number 1, a building which is 14 meters tall casts a shadow which is 32.4 meters long. Find the angle of elevation of the sun. So, in order to figure out the angle of elevation, we got to start by drawing a picture. Let's do that. And our shadow runs along the ground. And imagine if the sun was over here. We could literally draw a yellow line showing a ray of light coming from the sun that extends to the edge of the shadow. Now when we're looking for the angle of elevation, what we're looking for is this angle here. I'm going to call this A, my reference angle. And I know that this distance here is 32.4. And this distance along the vertical is 14 meters. You know that the angle between the horizontal and the vertical is 90 meters. So essentially what we have here is a triangle. A right triangle that extends from the top of the corner of the building all the way along the ground to point A. Now, we need to find angle A. We need to label the sides as adjacent, opposite, and hypotenuse. So let's label this as the adjacent, this as the opposite, and this as the hypotenuse. Now, because we have our adjacent, our opposite, and our hypotenuse, we can decide what we're going to do. So we'll write SOHCAHTOA here up at the top so we have our visual representation of what we're looking for. SOHCAHTOA. And now, remember, anytime we use SOHCAHTOA, we need 2 of 3 parts. We need, remember, with SOHCAHTOA, these always refer to 2 sides, 2 sides, and an angle. and one angle. And we always need exactly 2 of that 3 set. Now, let's look at our triangle. We'll notice that we have 2 sides. So, because we have 2 sides, we can easily find an angle. And in this case, the ratio that we're going to use is we're going to identify our angle by using tan. So tan is opposite over adjacent. Let's substitute accordingly. And now we have tan of A is 14 over 32.4. And we need to find angle A by finding the inverse. And when we do our calculation, we get A is equal to tan inverse of 14 divided by 32.4. If you have any questions about how to solve something using tan inverse, cos inverse, or tan inverse, refer to the previous lesson, lesson number 3. And we get the angle A to equal 23 degrees. And you'll notice that I'll put a box around my major angle. And then finally, we have to create a therefore statement. Therefore, the angle of elevation is 23 degrees. Now you'll notice that there were 3 parts to this question. The first part of the question is always identified by 1, the picture. You have to draw a picture of the situation. So go back to your word problem. Step 1, you're going to draw a picture. Step 2, you're going to use SOHCAHTOA. To find what you're looking for. And that is step 2. And step 3, the conclusion. And step 3 is our conclusion, so make sure you write that in our little box here. Now, our next problem is going to follow the same pattern. We got to draw a picture. We make sure we have the right picture, then we do our calculation. Now, remember, we're using angles of elevation and depression. All right, so let's do question number 2. It'll take us about 2 minutes. From a window, which is 10.2 meters high, draw our little picture, and here's my window. A person can see a hydrant that's at an angle of 65 degrees. So here's my fire hydrant. And I'm standing in the window and I can see a fire hydrant down on the ground. Now you'll notice if I draw a horizontal line from the fire hydrant back to the fire hydrant back to the building, it kind of looks like it's a horizontal line, but just imagine that our horizontal line kind of goes out this way and is very close to the ground. Now it says I can see the fire hydrant at an angle of 65 degrees, and it's an angle of depression. So what you have to do, anytime you hear angle of horizontal, angle of elevation or depression, what you need to do is you need to draw a horizontal line directly out from your vantage point. Then what you do is you draw an arrow showing that the line goes down, and then this is 65 degrees. Now because this is 65 degrees, I could use a Z pattern here. Let me just extend this line out a little bit. So imagine there's a Z. Where else is 65 then? 65 is right here. Now you also know that the angle between the vertical and the horizontal is, well, 90. So that means this angle here is 25 degrees. So you could use either one of these sides. I'm going to call this angle A, and I'm going to use that in order to figure out what the heck I'm looking for. I know that the height of my building is about 10.2 meters. I know I need to find the X, the distance from the building to the hydrant. So what we're going to do is we're going to take a moment and we're going to write SOHCAHTOA. I'm going to leave you to do the calculation and then pause this right now, try it, and then take a look at your final answer. Doing our calculations, we realize that we have an adjacent, and an opposite, and there's two sides and its angle. So I'm going to use tangent. Now because we've used tangent, we end up going through this entire stage of calculations, and then we end up with x is equal to 4.8 meters. The final stage is to write your concluding statement. And we have our concluding statement. So what I want you to do for your homework is, so on the back of the sheet that I gave you today, I want you to do 2 of these questions. Just 2. 2 questions. Understand that I will put one of those questions on a test. Okay? Now, the next one is you're going to, when you finish 2 of those questions, you come to me and I'll give you your handout. It's exercise 6.4. And you're going to do questions number 1 to 3, 6, 7, 10, 12, and 15. You can do these questions over the next day and a half. So tonight, I want you to do 2 of the questions. Tomorrow, you and your partners are going to be working on 3 through 15. That is on the handout page. Good luck.